say I want to solve a system of linear equations has this form. Ax plus by equals c, where a, b, c are real and dx plus ey equal f. A, B, C, D, E, F are real coefficient. Okay, so I can give you example. For example, no, you don't have to write this down. X plus y equal 5, 3x minus 4y equal 1 or negative 1, something like that. Right? So solving a system of linear equation. Both equations are linear. Now, if you were to graph the two equations, you may have many cases, right? The first case is two lines. Well, because it's linear, it's gonna be line, right? The graph gonna be line. The two lines gonna be intersect at one point. We're gonna call that system consistent because there's a solution, right? They intersect. If two lines are intersect or it has a solution, we call that system is consistent. If two lines are parallel, mean they have no solution, they're not intersecting, we call that system is inconsistent. So far, so good? Consistent means you have a solution. Inconsistent, you have no solution, in short, right? Now, independent and dependent is slightly different. If two lines are separate, then the independence, right? The independent, they're not two separate lines, right? So they independent. I don't care if it, I'm not talking about solution or no solution, right? I'm talking about how the position of the line, right? If they are two separate lines, you can see two separate lines, mean they are independent. If two lines are laid on top of one another, basically you only see one line, then the system is dependent. So the first two bullet points, we talk about the solution. The last bullet point is we talk about how many lines you can see, right? You can see both lines independent. You don't see one line, I mean those two lines are on top of one another, then they dependent. That's it. Oh. Let me ask you a question. The first system of equation, is it consistent or inconsistent? Because there's a solution, right? Is dependent or independent? Because you can see two lines, right? You can see two lines. The second one, is it consistent or inconsistent? Is there a solution? Or is it at least a solution? I think I forgot to talk about there. I should say at least one solution. If there's at least one solution, then the system is consistent, right? It's consistent. As long as you have at least one solution. So in this case, you have infinitely many solutions, right? They touch each other everywhere. Dependent or independent? Because, yeah, you only see one, right? And then the last one, inconsistent or consistent? Inconsistent, right? And it's the independent, right? Two lines. So you got to distinguish between the consistent, inconsistent versus independent, dependent. Right, let's solve. There are two ways to solve this. My favorite is elimination. Sometimes you can use substitution. Say, for example, problem 2, I would use substitution. The reason being because one of the variable is already solved for. Okay. Let's do number 2 first. Let's do number 2 first. What I'm going to do is I'm going to substitute x in the first equation with 2y plus 6. I'm gonna call number 1 circle, number 2 circle, mean equation 1, equation 2. Equation 1 is 2 times, well, x is 2y plus 6. And then plus y equals 7. So far, so good. Substitution. Substitute 2y into x. So y plus 6 into x. And now it's just a linear equation. You can solve with one variable. You can solve this. 2 times 2y is 4y plus 12 plus y equal 7. Combine like term. 5y equal, I'll do slowly, plus 12 equals 7. Subtract 12. 5y equal -5. Y equal -1. Once you have y, you can put into equation 2 to solve for x. Or your final answer will be 4, -1. Write it in order pair. So far, so good. Now, for problem 1, you can use substitution if you like. What you have to do first is you have to solve for one of the letter first. If you use substitution, I recommend you solve for y first, right? Because if you try to solve for x, you're gonna run into fraction. But I'm gonna use elimination. What I'm going to do is I'm going to eliminate y. You can eliminate x if you like. Pick something that make your life easy. I'm going to multiply the first equation by 2. Right? So I have 4x plus 2y equal -8. Rewrite the second one, 3x minus 2y equal -6. Now you add, it's called elimination. So one of the variables should be eliminated. 4x plus 3x is 7x. -8, -6 is -14. X is -2. You can plug in x equal -2 into one of those two equations. I'll pick the first one because it looks simpler. Use black. X is -2. Y 0. Now, without graphing, can you tell me this is the two problem, is it consistent or inconsistent? the system because you have at least one solution, right? Dependent or independent? Independent, right? This is two line intersect like that. You better see two. So that's the case where you have exactly one solution. Next, we're going to talk about the system of equation has no solutions. No solution means two lines are parallels. Do you want to do elimination or substitution? Let's do elimination. Let's eliminate x for a change. Multiply the first equation by 2. Do you get comfortable why I multiply certain equation by certain numbers? Yeah. You want the opposite. Pick a letter, pick your favorite letter, either X or Y. If you want to eliminate that letter, you better have the opposite coefficients. So I have negative 6x minus 10y equal negative 18. Six x plus 10y equal 1. 0 equal negative 17, which is not possible. So you stop, say no solution. Does mean empty set or no solution. You can write out no solution. Oh God, we almost done. I think I have to continue because I think we kind of behind the schedule because we lost one of the snow day. All right. Now the third one is system of equation has infinitely many solutions. This is 2 by 2. When I say 2 by 2, I mean you have two equations with two variables. It's not too bad. But when it goes to 3 by 3 and more, it gets hairier. Right? Let's start by elimination again. Like I said, it's my favorite. I'm going to choose to eliminate y. So multiply the first equation by negative 2, because I need an opposite coefficient for y. Then I have negative 2x plus 4y equal negative 2. Rewrite the second one. Zero equals 0. Always true. Always true. Do you stop? No, you don't stop. You're gonna tell me the possible pairs of solutions. So you have two lines kind of lay on top of each other. Right? Here's a technique. Pick one equation. I'll pick the first one because it looks simpler. I'm gonna solve for x. You can solve for y if you like. There's no wrong right this one, but I'll solve for x because I don't want to run into fraction. X equal 2y plus 1. So far so good. Basically, let me ask you a question. Forget about the black part, the part that I just wrote here. If you have 0 equals 0, does that mean any point that you randomly pick is automatically a solution? I'm just gonna just pretend that's your two line. Okay, they kind of lay on top of one another, the red and blue. So that's the solution. Do I just randomly pick any point and then it's automatically a solution? No, you're gonna pick the point that was on the lines, right? If you pick something out here, it's not a solution, right? So no, there's infinitely many solutions, but there's order, right? You're gonna pick the right one, the one on the line, on both lines, right? It can't just be anyone. So so like I said, I'm gonna pick one equation, solve for one of the variable. Now you can stop right here. There's nothing wrong with this. Now you can pick. If you pick, say, if you pick y is 0, then what is x? You plug it in there. 2 times 0 is 0 plus 1. So x is 1. Yeah. You pick another one. You pick y is 1. 2 times 1 is 2 plus 1 is 3. So when y is 1, x is 3. You can pick another one, say negative 2. 2 times negative 2 is negative 4 plus 1 is negative 3. So negative 3, negative 1. I'm sorry, negative 2. You can pick anything for y. Then you have x, right? And that will be your solution. Those solutions in yellow, they call particular solutions. Of course, there are infinitely many. Just give me a few. Now, in mathematics, we don't want you to write like that. I know there's nothing wrong with it, but we use a different techniques called, we use the parameter. So we're gonna let y equal t. Well, Mimi, why don't we let x equal t? You can. Nobody said you cannot, right? But it's just easier for me to let y equal t because I don't want to run into fractions. And I don't want to resolve for t, right? So let y equal t, then x equal what? Instead of 2y, it's going to be 2t plus 1. And t is your perimeter. In mathematics, we call that perimeter. I know it's kind of like, why would we use extra, why we do an extra step for nothing, right? This is good enough. You go high in math, it makes more sense, right? And now you don't see it as much, but as you have many, you have more equation with more variables, it makes more sense. And it makes sense when you go to linear algebra, when you do vectors. Here I'll just introduce to you so you don't feel like it's the first time you hear it, right? So your solution, your final solution will be in order pair x, y. X is 2t plus 1 and y will be t. On the exam, I want you to use the parameter just like that. The one in yellow is particular solution. The one in blue is the general solution, which is the one I want. If I want a particular solution, I'll ask for it, but you still have to give me the blue one. I want you to do problem 2. I'll walk around, see how you do. Because I was so busy, I just got back in US and last Sunday morning. I didn't have time to put in the extra credit. Wednesday, you have it. Wednesday, I'll put extra credit things on Moodle. Oh, you're supposed to multiply the opposite. Just solve normally, like solve. Everybody may have a different answer, but that's okay. I'll tell you to check your answer, even though you have a different answer than your friend. Naturally, I multiply the first equation by -3. I have -3x plus 15y equal -9. Rewrite the second one. So 0 equals 0. Next, I'm going to pick one of the equations and solve for one of the variable. It doesn't matter which one. Pick something simple. So I'm pick the first one. X minus 5y equal 3. I'm going to solve for x. If you want to solve for y, that's fine. There's nothing wrong with it. And then what do? We let what equal t? Y equal t. If somebody else let x equal t, that's fine too, but you have to solve it back, right? If you let x equal t, you have to solve for y, which is more complicated than we wanted to. Then this imply x equal 5t plus 3. So your final solution will be 5t plus 3 comma t. Now, if somebody solve for y and you have a different representation, it's okay. Let me tell you how do you check. If you and your friend have a different representation, you can check by plug into a number. Say, I want to pick t equals 0. Then y is 0. Then x is what? 3. You and your friend both should both have 3, 0 in one of the particular solution. Then you know that you got it right. Kind of like log. There's many ways to solve a log, but as long as the approximation are the same, then you know that you got it right. Any question? Is there any question?
The one in the yellow is called
Particular solution. Particular or specific solution or whatever. However you want to say it. All right. The application. When we finish this slide, we're gonna jump to 5.2 because we kind of behind. The Johnson Farm has 500 acres of land allotted for cultivating corn and wheat. The cost of cultivating corn and wheat is $40 and $32 per acre, respectively. Jacob Johnson has $16,800 available for cultivating these crops. If he wishes to use all the allotted land and his entire budget for cultivating the two crops, how many acres of each crop should he plant? So we're looking for the number of acre for each crop. They already denote things for us, which is nice. Let X and Y denote the number of acre of corn and wheat, respectively. Can someone come up with the first equation? Should be easy. Yeah. Yeah. Everybody see that. Second one. Mm-hmm. I know it say formulate, but do not solve. But let's solve. Let's solve for this. Just for the sake of practicing. You want to use elimination again? Well, so let's do substitution. X equal 500 minus Y, and substitute into the second one. 40 times 500 minus Y plus 32Y equal 16,800. 40 times 500 is 20,000 minus 40Y plus 32Y equals 16,800. Negative 40Y plus 32Y, that's negative 8Y. 20,000 and 16,800 is what, 3,200, right? Negative 3,200. Yeah. Divide both sides by negative 8, Y is 400, right? Acre. This is corn, right? This is corn, so acre of corn. Then you plug into the first one, you want to substitute to solve for the wheat. Sorry, is it wheat or corn? Wheat. Why is wheat? You know, it doesn't matter. We already know just acre. We already know the variable. X is 500 minus 400. 100 acre. This was easy. This slide is preparation for the next one. If you have something like this on the exam, don't mess it up. All right. So that's the end of 5.1.